Good afternoon, and welcome to sunny Seattle. My name is Ted Wei. I'm a program manager on the Azure Machine Learning team. Here talking about just a brief introduction to data science. Give you a little bit of background about myself. I come from the image processing world. So my dissertation project in grad school was to take images from lung cancer, CT scans. So if you were to go to the hospital and get a CAT scan, you'd basically get about 600 of these slices. This is one slice of a lung that you're seeing, looking at someone from the top of their head to the bottom of their toes. And as a radiologist, it could be after lunch, and you got 600 of these images to look through, and you're trying to figure out where's lung cancer. Could be 1 to 3 millimeters wide, and you're trying to predict whether that's malignant or benign. And so this is really just the motivation for data science in the sense that you have a ton of data, massive amounts of data, trying to run algorithms and predict and be able to use lots of tooling on top of that data. So today, I'll just be going over just some of the fundamental basics of data science, just some of the tips and tricks, just to get you start thinking about what it means to approach a problem as a data scientist, and then mapping that to Azure Machine Learning. So being on the Azure Machine Learning team, basically understanding the process, how that looks like in a tool like Azure Machine Learning, to be able to build your own predictive model and to be able to expose that as a REST API. So all of this to ask, what is a data scientist? And you've probably heard this before, but data scientist just happens to be a data analyst who lives in California, right? And so there's just a lot of ambiguity and just a lot of like, what's a data scientist? Kind of like a doctor today. There's really no good definition of a data scientist in the sense that, you have doctors who are general practitioners, who are radiologists, who are, specialists in various areas. And so people who are data scientists do everything that a data analyst might, from ingesting data, processing the data, to building predictive models, to basically doing predictive analytics. But, all joking aside, I think there's some elements of being a data scientist that are a little bit broader in the sense that you're generating questions. So you're not, being asked to do something. There's no question being asked of you to go for. There's a bunch of data, and you just need to figure out what kind of questions to ask. This is kind of the science part of it, right? Coming up with your own questions. Using things like machine learning, being able to know what the algorithms are and being able to apply them on the problem you're trying to solve. Working with big data, mainly could be very unstructured data like image data or sound wave data, things like that. Having some business acumen, understanding what the business is trying to do, and then trying to figure out how to apply these tools to the data that you have to solve these problems, and then storytelling. So again, as data analysts, the skills are overlapping, right? I don't think there's this mystical data science, occupation that is just so far out there. But I think you'll find that a lot of the skills that you have overlap with data science. And so the question is, what are just some of the ways of thinking about it, and how to use the tools to be able to apply it? And so just to kind of think about it from a data analytics and data mining perspective, some of the main goals might be just finding insights in large databases. You might be using SQL, and then you have large data sets, right? So these are very, very well-defined problems and well-defined data sets to be able to answer those problems. The folks who focus on statistics might be more on emphasizing the theory behind everything, and they're in the realm of mathematics. R is probably their language of choice, but at the end of the day, these are all just big Venn diagrams with lots of overlap. For the folks who do more machine learning, this is coming from the engineering profession, and they're actually building the end-to-end solutions to be able to take that data and run the predictive models and show the results. They might use something like Python, and this is dealing with high-dimensional and large data sets. So again, lots of overlap. The things that I'll probably talk about today are probably already well known to you, but again, it's just about just putting that into some framework that can then be applied to a tool. So some of you might have seen this before in terms of going from hindsight to foresight. The kinds of stories that you can tell with data. So I like to tell the story of ThyssenKrupp. ThyssenKrupp is an elevator company. And so if you need to, say, get downstairs to the next conference room right after this, and you need to take an elevator, maybe it's broken, and maybe you're stuck in it, right? So 3 months later, ThyssenKrupp, the elevator company, might get this report. And the report just tells the what happened story. And the what happened story is, well, at the Washington State Convention Center, the elevator broke down. And that's a bummer. Well, too bad. And it's a very, very backwards-looking story. It's not too valuable. But then you might have your data folks that look into the data, and they might be able to tell the why did it happen story. And the why did it happen story, after analyzing the data, they found that this pump that was supposed to last 10 years only lasted 3 years, and that's why it broke, and that's why the elevator got busted. But it's still not a valuable story. It's still something that happened in the past. So how do you get to going from hindsight into something like insight, where you can start telling the what will happen story? So what ThyssenKrupp is doing today is just putting sensors on their elevators, running those sensors, the data coming from those sensors through a machine learning model, and being able to predict when something's about to break down. So now they can start telling the what will happen story in that, this pump, the data coming off of it is indicative of something that's about to break down. And then they can finally tell the how can we make it happen story. So let's get a maintenance crew out there. Let's fix that pump. And now you can get to your next session because the elevator's fine, right? And so the power of advanced analytics, predictive analytics, is really just being able to take that data and be able to apply these machine learning algorithms to it to be able to tell better stories, specifically around the what will happen and how can we make things happen story. And these are the valuable stories that every business wants to know. Right? We can all be reactive, just like getting a lot of data. Maybe your boss is asking for answers to a question, and you can go look in the data and present that answer, but you can also start exploring the data and being able to do some predictive analytics on that data. So some of the use cases, just from a advanced analytics perspective, spans pretty much the spectrum of everything. From a personalization perspective, for those of you in industries where you're dealing with a lot of end customers, recommendation engines, you're probably very familiar with them online. Every time you go online, it seems like they know more about you than your spouse might know about you. It's because they're able to mine that data and be able to give you some recommendation. Customer churn. When is a customer about to leave? We work with Tacoma Public Schools to be able to identify students at risk of failing out of school. And this is an example of student churn. But once you identify those factors and you can intervene early, Tacoma Public Schools actually, I think they saw their graduation rates go from 55% to about 83% because of advanced analytics, where you identify the students, intervene early. Just like you can identify customers, intervene early before they churn out. Identify employees before they're about to leave your company, intervene early. Anomaly detection, so as data is streaming in, IoT scenarios, Internet of Things, to be able to process the data in near real time, and then to be able to apply models on top of that to detect when something might go wrong. Operational efficiency, again, like the ThyssenKrupp example, data's streaming in, you're able to predict when something might break down. Demand forecasting, everything from inventory to prices to profits, et cetera. So anytime you have data, you can think about how you might want to apply that data. So I'm just going to cover the Cortana Intelligence Suite real fast just to give an idea of where we are in all of this. But the idea is that you have data, and that data needs to be ingested, could be combined with existing data. You might have hot paths and cold paths. That data is ingested, you process the data, and then you take action based on that data. Could be an automated system, like opening a ticket to a support crew. It could be a human, on a fraud detection scenario. Someone gets a ticket that says, something's happening here that we think is indicative of fraud. And so just the next level down is just a set of services on top of Azure to be able to spin up, to hook them together. So you have your information management portion where you're doing data ingestion using something like event hubs to be able to take and ingest millions and millions of events per second. So every time a customer swipes, every time a customer clicks, that message is ingested. And then you use something like Azure Stream Analytics to process that data in near real time, and then run that data through a machine learning model. And so, and then show the results on something like Power BI. And each one of these services can stand alone, or you can hook them together into end-to-end solutions. So in this case, we have a solution that predicts when cars are about to break down. And I'll show you later in the gallery how you could spin up this solution in Azure. But again, you have your data generation, your data ingestion, data processing, run it through a machine learning model, and show it on something like Power BI. And machine learning could stand alone. Basically, the model is exposed as a REST API. And so if you have an existing data pipeline, you don't have to throw away everything and start over. You can just have your data, call that REST API, get your response back, and then do some things with the data. And then you can do batch processing over the entire data set in your cold path. So let's actually go to the meat of this talk, which is just talking about data science in general, just some of the mysteries or the tips and tricks behind data science. And it's not magic. At the end of the day, it's math. A lot of the things we all already know, right, in terms of the algorithms, in terms of the statistics, but it's just formulating a framework to approach a problem. And so really what I'll cover today are just these 4 areas. One is just knowing your data, the importance of knowing your data. 2, knowing the question that you're going to ask. Knowing your domain, the importance of knowing your domain, and finally, knowing how you're going to use your answer. So let's start with knowing your data. So tonight, there's probably going to be a big party where all of you are going to celebrate, being at the Data Insights Summit. And tomorrow, I want to predict, or actually maybe at 3 a.m., I want to predict your blood alcohol content. Right? And so how do I predict your blood alcohol content? I might have some data. And the data that I have is the price of milk and the batting average for our Mariners, right? I don't know how good that data will be in predicting. And this is just a toy example, but just to illustrate the point. Because you might face a lot of situations where people are saying, hey, we're sitting on a ton of data, and data's valuable. We can get insights out of this data. So get insights out of this data. And you're like, well, the data is absolutely useless in order to predict what I want to predict, right? So it's very, very important to know your data. A lot of hype today around machine learning is that you have a big data set, you apply magical machine learning to it, and you get rainbows and unicorns out the other end. And that's not really the case. You really need to know your data and know what you're trying to get to. So relevant data, if I had your body mass and I had the number of margaritas that you drink tonight, then that would be a very good way of predicting your blood alcohol content, right? Again, so you never know just how many situations in which you're presented with this database and asked to do things that you can't do because of the irrelevance of that data. You might have some disconnected data. This might be familiar to all of us where, in this case, we're trying to predict a burger rating. And in one data set, we have the rating, and we have the grill temperature at which that burger was cooked with. We have the weight of the beef patty. You join the data sets, and it turns out there's a lot of data missing, right? And so what do you do with that data? You could say, OK, I'll just throw away the data where it's missing, but then you might lose a lot of valuable data. So how do you get good connected data? This is where knowing your data is very important, because then you can do things like, OK, how do I fill in those missing pieces? Do I need to go upstream, and I need to do something to be able to get better data? So the ability of having a good data set, connected data, is very important. And then it's the amount of data. So in this case, let's say I asked you, in the summer, how many of you are willing to devote 1 week and $10,000 to go here, right? And so I don't think that's enough data to make a decision, right? And you wouldn't believe just how often we get faced with a situation at work where, again, someone presents you with a data set, or someone says, hey, make this prediction, and this is the data that you have to work with, right? So then it's incumbent on you to be able to go back and say, I need more data to make that decision. And you might get a little bit more clarity, and you might be able to make a good decision, but then when you finally have enough data, that's when you can make a better decision. And so it's very, very important to be able to know just when you have enough data to make that decision. So the next segment is on knowing your question. And this is just starting out with the right question to ask. It's very easy to start with vague questions, and vague questions are basically, we just define them as questions that cannot be answered with a name or a number. Someone might ask you, hey, here's some data. What can it tell me about my business? Right? That's not a very good question. You'll have to go back and push back and say, you know what? I need a question, or I need to generate a question, or I need to translate that question to one that can be answered with a name or a number. Such as, rather than, OK, I have data, what can it tell me about my business? But how many units will I sell in Seattle next quarter? Right? So you need to be able to translate these ambiguous questions into one that you can answer with a name or a number. Such as, or how do I ensure reliability of my service? I don't know. But if I can build a model around which car in your fleet is about to fail first, then I can give you a better indicator of the reliability of your service. Or the greatest general question, what should I do? And so, if your boss comes and says, what should I do? how do you translate that into a question that can be answered with a name or a number and build a data model around that, such as which feature is most predictive of fraudulent transaction. And so you need to start with a very good, sharp question. And the types of question that you ask will be the types of algorithms that you're going to use. And again, no different than I'm sure what we do a lot in our day-to-day jobs. It's just a matter of probably expanding our portfolio in the types of algorithms that we know about and which algorithms can be applied to which types of problems. So some of the major chunks of problems that are asked, you might have a how much, how many type question. You might have a which category type question, which groups, is it strange, which option. And so this determines the algorithm. So starting with a how much, how many questions. Basically, what you're trying to predict is a number, right? Could be the temperature next Tuesday. It could be, how many sales you're going to have or how many new followers you're going to have on Twitter, right? This is where you're going to use a regression model, and you're probably already familiar with regression to be able to take in the data, and the output of that will be a number. So this is a regression type problem. Next one is which category. And so if you're given an image, is this a cat or a dog? How many categories are you going to define? Or which aircraft is causing this radar signature? What's the topic of this news article? Right? So you need to use a classification type algorithm, but then there's also a classification type algorithm on the data output of algorithms upstream. So in order to be able to analyze these images, you might need to use things like deep neural networks to be able to analyze the image to give you the right output to run through a classification algorithm. Which aircraft is causing this radar signature? Again, an image processing scenario. So knowing that upstream, you have to have the right algorithm to do the classification or topic extraction, something like that, to do your classification. So which groups? This is your clustering scenario. So you might be looking at a bunch of data about all your various shoppers, and you're trying to cluster them into various groups. You would need to think about how many clusters do you want, and once you have these clusters, what are the various characteristics of these clusters? So which shoppers like the same kinds of vegetables, like the same types of movies, natural way to break these documents, right? So using clustering algorithms to be able to answer this type of question. Is this strange? This is where you're getting into your anomaly detection algorithms. As again, going back into the ThyssenKrupp example, as data is flowing in to be able to run anomaly detection on it, is the trend going higher or lower than you expect? Are there strange things that are happening? These are blips. So there's a difference between the supervised and unsupervised machine learning, where in an unsupervised machine learning where the data is flowing in, you might not know anything about the data, but you might learn what's normal over the course of time, and then when something abnormal happens, it'll tell you, anomaly detection algorithm will tell you something is abnormal. And then at least then you can go do something about it to see what it is. And so classic scenarios such as spam detection in emails, or anything you might have like with a credit card. So you use your credit card, and then your credit card company calls you and says, hey, this is a very strange transaction. It's not very indicative of your pattern of purchases. So you'd be using an anomaly detection algorithm in this case. Next one is the recommendation engine. So you might use something like a Matchbox recommender or anything else to be able to do recommendations. And in this case, you would be taking a lot of data, maybe past purchase history of your various shoppers. You're again combining things together. So this is where you might cluster them into various similar groups and then predicting which options that they would like. Just like you go on Amazon, you put stuff into the shopping cart, and Amazon's really good at helping you spend more money on Amazon because it knows your demographics, it knows what other people have purchased, and it knows what to recommend to you. And then should I buy other things? Or like the Netflix scenario where they run a recommendation engine and be able to show you what kind of movie it thinks you might like. So these are recommendation type algorithms. And so knowing your domain is the next part. So knowing your data, knowing your question. And this goes back to knowing your data. Because as we saw in the earlier example, when you have missing data, what do you do? So as a data scientist, as a data analyst, someone who's working with the data, it's very important to work with the subject matter expert to understand that data, to be able to correct for missing values. You could, as I mentioned earlier, you could throw away all that data, but then you're losing a lot of value. So you might be able to correct for missing data. Maybe you'll take the median. Maybe you fill it with all zeros. Maybe you fill it all with 10,000, right? So you know best what's the best way to be able to fill in those missing values so that you can have better data to be able to build a more accurate predictive model. And then you can build, and you can move upstream to be able to worry about collection flaws, right? So depending on kind of where your segment of expertise is, maybe you're just given a data set and you have to do things with the data set. But where did that data come from? So some of the data engineering work of data ingestion, of being able to have a good data set. These are things that you might need to push upstream to be able to figure out what was wrong in the data collection. Feature engineering is just a process of being able to add more features to the data. So you might have, some data set, you might have 5 columns or 5 features, and that might not be enough to be able to build a predictive model. And so in this case, you might want to add more features to the data so that you have something that would build a better, more predictive model. So some of the things that you could do, especially for the IoT scenario, things like rolling aggregates or lag features. So these are ways that you could add more features, especially if you're getting time series data, to be able to add these with where you're aggregating, say, the last 5 data points, averaging that and having another data point. This is just one way that you could augment the data to be able to have a better data set. So in this case, we have 2 columns of data, and we're trying to, column 0 and column 1, and we're trying to predict the values in column 2. So this is, you can think of this as a regression problem. So I have 2 data points, and I'm trying to predict a third one. And you can see if I do a scatter plot of each individual column with what I'm trying to predict, I don't see any patterns at all. It's just all over the place. The coefficient of determination is very low. This is your R-squared value. In Excel, when you have a curve or a line and when you're trying to fit something, your R-squared value is an indicator of how good that fit is. So this is very low, meaning that I'm not predicting anything from this data. So you might say, okay, so I'm just going to do some feature engineering and I'm going to randomly multiply 2 values together. And I have this third column. And great, I have more columns. Is this going to help me? And you look at the new feature, the new column, and I'm going to plot it, do the scatter plot against what I'm trying to predict, and it doesn't help at all, right? So this is just, adding more noise, trying to do some feature engineering that, where you're trying to add more features might not help. And so this is where the subject matter expert is critical, because then they might say something like, okay, actually, this is data that's coming from a sensor. Column 0 is just time 0, t0, and column 1 is just time t1. Knowing that, then you can do some better feature engineering and say, okay, what if I just subtract these values and create a new feature? And then when I try to do my regression on that, you can see that it's a lot better in its predictability. And so again, this is just one way where you can add to the data set to be able to create a better data set. Finally, it's about how you'll use the answer. And so to think about, what are you trying to ask and what are you trying to get to? Are you trying to do binary classification, where you're predicting 2 classes? Are you doing multi-class, where you're predicting multiple classes? You might be doing regression, where you're trying to predict a number, anomaly detection. How are you going to use the types of modeling techniques? And so this is just an example of how you might label that data. If I were doing a regression when I'm trying to predict, I might have a column. Like ThyssenKrupp might have a column that says, here's the number of days where we had the sensor reading and the number of days until it broke down, right? And so that's just a number. And that's the label that I'm trying to predict. I might be doing binary classification, yes or no, 1 or 0, right? So if I have my favorite Titanic data set of passengers who might survive Titanic or not, basically 1 is survive or 0 didn't survive, right? Or I might do multi-class classification. I have lots of data and I'm trying to predict them into multiple classes. This is just one way of labeling the data, because your algorithms will need to know the label column to be able to know how it's going to build that model. So putting all this together, this is just the summary of the data science process. And you start with your objective, right? Again, going with a very sharp question. You're starting with a very sharp question that could be answered with a name or a number. You know the data that you have. So bringing this all together, you have your irrelevant data. You want to get some relevant data. You have your disconnected data. You want to get to a way that you can have your connected data. You're doing some pre-processing. So people talk about building these models and doing all these cool things with data science and machine learning and all that stuff. All the sexy stuff is probably only 20% of your time. 80% of your time is still going to be spent in data ingestion, data cleansing, data processing, and getting to a good data set. And I think just to be very realistic about that and set the expectations, most of your time will be done doing that. The more you invest in being able to have a good data set, the better your outcome will be. So let's say you've taken that time to build that good data set. In this case, we're just doing a supervised learning where we have our historical data. And then we're going to split our data sets. And the way I like to illustrate this is before we train a model on this data is imagine that we're all back in college and next week is the final exam. So I have a set of 100 questions and 30 of those 100 questions will be given to you on the final exam. So if I give you all 100 questions and let you study it, next week I pick 30 and I test you on it, I expect you should do pretty well, right? Unless you've been drinking all these margaritas at the Data Insights Summit. But you should be doing pretty well. And that's not an honest way of assessing whether you know the material or not. The honest way of doing things would be I should give you 70 of these questions. I'm going to reserve 30. You're not going to be able to look at them. You study these 70 questions, and then next week at the final exam, I'm going to give you these 30 questions. If you do well on these 30 questions, then I know you probably know the material. So that's what's happening here in that split. I'm splitting my training data into a training set and then a test set, and then I'm going to apply an algorithm on that training set. So basically, this is like the studying for the final exam portion. And then the test set, you apply that trained model onto that test set. This is where you're actually taking the final exam. And if you do pretty well, then you know that this is a good algorithm. And there's a lot of different methods for splitting the data set. There's a lot of strategies for cross-validation where you might train on one data set, test on the other, train on this one, and test back on this one just to see if everything's consistent. A lot of different ways of doing that. But you're basically trying to train an algorithm, train a model, and apply that to a test data set. So once you have this model, the next step is to be able to put it into production. Right? Typically what ends up happening, unfortunately, is that you might have a data scientist and you give them a problem and you say, hey, why don't you predict for me in my big data set whether my customers are about to churn out. So the data scientist goes back and writes some Python code, writes some R code, or builds a model or something like that, comes back with the results, does a presentation. It's beautiful. Everything's great. The problem is it only runs on their laptop. How do you actually get that model running into production? So you need to deploy that model running in production and then hook it up to basically your end-to-end pipeline if you want to be able to predict things on the fly, for example. So you would need to deploy that model. Once that model is deployed, you can hook it up, and then it can process, give you back your predictions. And over time, you might want to retrain that model as more data is coming in. For example, you might have a recommender model, recommender of this is what I should show the customer when they come to the web page. These are the things that I should show them. And the customer clicks on it, that should be a signal to your model that it's doing pretty well. Customer doesn't click on it, another signal to your model that it could be improved. So you might want to retrain your model and then expose it again to be able to have a better model in that way. And so this is just the process in which we do that. So let's talk about credit card fraud detection using something like Azure Machine Learning. And I'm going to start with the Cortana Intelligence Gallery. So the Cortana Intelligence Gallery is our collection of templates. Just like in Word, you have your resume template. In Excel, you have your budget template. This is a collection of templates to get you up and running very quickly. For example, if you wanted to do something like vehicle telemetry analytics, you can go here with your Azure account and click Deploy, and this will deploy all these services that I just talked about. It's going to deploy a synthetic data generator. It's going to deploy an event hub that's going to ingest this data. It's going to deploy stream analytics that's going to process this data, going to deploy machine learning that's going to do a prediction on the data, and then you can hook it up to Power BI to be able to show which vehicles are at risk for breaking down, essentially. So this is one way to get up and running very quickly, so that if you're not very familiar with Azure, this is a way that you could just have everything running end to end, and then you can modify it just like a template, like a resume template. You would put your name instead of whatever name's in that template, and that way you don't have to spend a lot of time trying to figure out how to provision things and how to hook them together. So in this case, we also have some templates for other experiments, but I have here credit fraud detection, and this is just a very, very typical data set. I might have various customers, data from various customers, their credit card number, whether they went to a grocery store or a supermarket, how much they spent, the timestamp where they had the transaction, how much they might have spent in the last day or the past 7 days, et cetera. So this is all the data that you have, and you might actually have whether these transactions were fraudulent or not. So this is an example of that supervised learning. I already have a data set. I already know which transactions were fraudulent. I already have these features about these various transactions. Let's build a model around all of this. This data set is just a CSV, but if you want to import data, you can also pull in the import data module. And if you have data on Amazon S3, that's totally cool. No, that's fine. It's exposed as a URL. You can bring that in. If it's on our Azure HD Insight clusters, if it's on our Azure storage solutions, such as SQL, Blob, or Table, even something like DocumentDB or Cosmos DB now, and even if you have an on-prem SQL database, you can connect to it to bring in your data. So this is really just how you would be able to easily start building a machine learning model. So bringing in the data, ingesting that, and then each one of these modules can do something to the data. So in this case, I'm just doing some very simple metadata editing. I might be doing some cleaning of the missing data. And for any Python or R users, actually, let me get a show of hands. Who knows R or Python? Any Python or R? Oh, sweet. OK, great. OK. So you're all very familiar with this. And if you wanted to bring in your Python or R code, you can also do that here. So let's say you didn't want to drag in 5 different modules to do something. You can just write that code, connect that up, and do it here. Or if there's anything out in open source in your libraries that you want to import, you can just bring it in here to be able to build your model. So in this case, all you do would just be bringing that in. And then you could do something like this to be able to run your Python script. So here, then this is where I'm doing the splitting of the data. I'm splitting the data set, and I'm training it using a 2-class boosted decision tree. And then I'm going to apply that to the test data and then look at the results. So running this model here, this is just what we call experiment, to be able to experiment quickly, to iterate quickly, bring in your data, build a predictive model around that data, and then look at how that model is performing. You can look at and then you can look at the results. Apparently, this is an amazingly good model with 0.99 accuracy. But if you don't have such high accuracy, this is where you might look at different algorithms. You might look at adding additional features. You might be doing some feature engineering. These are all the things that you could do. Rerun your algorithms. Look at the results. And once you, oops, let me go back here. And once you like your model, you can then deploy that as a web service. So once you have that model, whether you have your R code, your Python code, you can deploy that as a REST service, a REST API. And then this is deployed as a REST API. And you can see here, this is now available to to be accessible with anything that can call a REST API. So if you have an existing data pipeline that is ingesting data, that's doing a lot of processing, you don't need to throw it all away. All you have to do is have whatever part you have the data, call the REST API and get a prediction back, and then you can take action based on this, based on the result. And in Excel, we have an add-in that can connect to these machine learning APIs. So you can go to Excel and go to the store and look for the Azure Machine Learning add-in and be able to connect to that. So in this case, I have a bunch of data about different customers and their credit cards and just various amounts, how much they paid and transacted. All of this data I can send and go predict. And you can see here with the scored labels, you can now see which transactions were good and which transactions were fraudulent, right? So this is just an example of easily building a machine learning model, exposing it as a REST API, and then be able to interact with a model. So now you can do things with a model such as your what-if analysis, and it's not just restricted to numeric data. You can do text analytics. You might have a text analytics model that does language detection or does sentiment analysis. You can expose it in the same way, put your strings in Excel, run it through, and be able to get your responses back. And this is just an Excel add-in to be able to expose to users who might not be familiar with machine learning, but now you have a machine learning model to help them do their predictive analytics. And we actually do this in Microsoft today. Amy Hood is our Chief Financial Officer at Microsoft, and her team does something like this where we have sales forecasting models. Microsoft Treasury does a lot of currency hedging, so we have currency hedging models. So they know Excel, they have all their data in Excel, they run it through the models, and then they can help us make better data-driven decisions in this way. So how do you quickly get to the point where you have a model, where you can expose that model, have people using the model, and then building on top of the model, having the right tools to be able to bring it all together. So given that this is a Power BI conference, I'll spend the last 4 minutes on Power BI. I'm on the Azure Machine Learning team, and so all the Power BI folks are probably like, okay, what's going on here? So Power BI is, of course, as you know, very powerful and very cool. Has the ability to write R scripts. And this is the same model that I have. So what you can do is use an R script to be able to connect to that Azure Machine Learning model. So again, it's just a REST API. And here, you can see here, and I can make this code available, but credit goes to Christian Berg for writing this and sending this to me. But basically, your Azure Machine Learning Web Service just needs access to the API key. So within R, you're able to connect to this web service, and now you can send data from Power BI to your predictive model and to be able to visualize the results. So for example, I have these various customers, and this is just an R visualization of the percentage probability that this transaction was fraudulent. So you can see here, if I add the data for all the customers, let me add this here. And these are all the great things that you can do with Power BI that you know and love, but integrated with R. Right, so with the R visualization. And so now you're connected to your machine learning model. Your data can be run through it. You can do your analytics, and you can visualize it. So you have the ability to expose to the other people in your org Excel to be able to run that model, and something like Power BI to be able to visualize these things. And in that way, it's more powerful to help people make better data-driven decisions, because now the results that are coming back they're able to take that. So if they don't know machine learning, no problem, you got it covered. If they don't know Excel, you got it covered. They could look at a picture. All they have to do is go to a dashboard, look at that picture, and make a better decision. And again, you as a data scientist, to be able to build this end-to-end pipeline fairly easily. And so the experience that we have on the machine learning team as we go out and engage with customers, every business already has their infrastructure already in place. No one's going to want to throw that all away and start from scratch. But the most success that we found is when you start with a very, very small proof of concept. So you might have a problem, maybe there's a problem that, the management has been asking, or someone, your coworker has just been vexed with it, and you have the data. When you're able to take that data, build a very simple model around it, expose that in a way that people can consume very easily, then they'll start asking questions about it. It's, you look at something like this credit fraud detection. They might ask, are there other features that can help us build a more predictive model? How do I make better decisions on if I do detect a fraudulent transaction? How do I do this? Or what is the impact of fraud on my business? They can start asking these problems, and then you can start improving the model. As you get more adoption, as you get more organic adoption, then I think we found in the customers that we've worked with, then people start getting excited about this. And your value just increases because now you have the ability to be able to improve the model, to be able to help people consume that model, whether through Excel or Power BI, and then answer some of the business questions that has been just harder to answer. So there's a ton of low-hanging fruit out there. There's a lot of data. I think we're all very aware of all the data out there. We're all aware of just the where we're at, but I think there's a huge opportunity to be able to take that data, apply these tools, and answer these types of questions. So using things like, again, if you have this is just the percentage average identification of risk, and again, using R visualization to be able to do these rich types of visualizations where you're combining R, where you're combining machine learning, and be able to surface it in something like Power BI, you'll help people make better data-driven decisions. So with that, I'd like to reserve some time for questions, but hopefully this gives you an idea from a data science perspective of the framework of how you would think as a data scientist, how you would approach knowing your data, knowing your question, knowing your domain, knowing how you're going to use the answer. But once having that knowledge, knowing the tools that you can use to easily get to something that then you can make of value to your coworkers and to your business. So I wish you all much success in this endeavor. If you have any questions, feel free to email me. But we have about 8 minutes left for questions. So thank you very much. So we have some microphones on the side here. If you have any questions, feel free to ask questions. All right, cool. If not, I'll just be sticking around. Thank you very much for your time. Thank you.